Hello, good morning, good afternoon, good evening, whatever time of the day you are watching this. Welcome to uh, my JAMB preparatory platform. Today we are going to look at some key questions in physics that you are likely to come across during your JAMB exams. Oh, if you are my returning students, uh, welcome back. It has been a while. I miss you guys so much. Work has been too much on me, but God has been helping me, and currently I'm close to completing my studies. Okay, if you are just coming across my video for the first time, my name is Emmanuel. I'm a jump coach. I have a group of students I've been working with, giving them guidance, assisting them to see that they emerge among the top in jump this year. So I've been with them for quite some time till when my studies had to take me away for a while. So I'm back. And now, my people listening, we are very close to the D-Day. Yes. So what I would advise now, uh, I would advise that you should give more attention to past questions. If there is any syllabus you have not covered, if there is any preparation you have not done, I would advise at this point in time, just concentrate on past questions. Very, very important. Now, if you remember, when we first started, uh, I had to, be going through syllabus because I want to cover everything. I want to make sure that whichever way the exam comes up, you should be able to answer. Uh, then we continued, but we at a point in time when I had to leave to face my dissertation research, I we had a very long break that I didn't come up with anything. So this time around, as I'm coming back, I know we don't have time again. So a kind of looking at past questions, I want us to concentrate on them now. So I'll be giving less assignments now. In fact, I don't think I'll give any assignments. So I will just be treating the past questions together with you, so that we can see how God will help us to hasten our uh, journey. So this morning we are going to look at JAMB Physics past questions in 2024. If you are not my student, sorry, you may not be understanding what I'm speaking, but you are welcome. I believe that for you to have come across this video, you are one of those candidates who also are aiming higher in JAMB this year. And I pray that God will grant you that. And as you press on to prepare, sorry, let me just put some things off so that I will not be interrupted. Okay, so I believe that God will help you. So welcome, and let's go right into it. This is JAMB Exams Physics 2014, and we are going to treat only 20 questions in this video so that it won't be too long. Okay, so the first question says, what is the least possible error encountered when taking measurements with a meter rule? Now, there are different kinds of errors in measurement, in scientific measurement. In fact, there is nothing like exact. Exact. All measurements are more like approximates. I don't know if you get that. You will hardly measure accurately. No. Yeah, if you are given water now and are asked to measure 1 liter, exactly 1 liter, it will be very difficult for you. You will just look at the measuring bar and say it is 1 liter, but you can't tell whether it is exactly 1 liter. So that's the point. So I have treated errors before, standard errors like zero error, parallax error in one of my videos in physics. I remember dealing with that very well. And if you have not watched it, just go to the channel, check the videos on physics. In fact, I've arranged all the videos now. Yeah, in playlist. Physics has its own playlist, biology has its own playlist, and chemistry has its own playlist. So you can go and check them. So you need to understand these errors because you must answer question under here. You need to know. That's why they should ask you. I always told you that this is the secret. Anything that is important for you to know, that JAMB feels it is important for you to know, then they will test you to see if they know. That's just the secret. So now, if you are talking about meter rule has usually we encounter zero error. Remember, zero error is due to the instrument, the measuring instrument. Yeah. While when we talk about parallax error, we're talking about human error. Maybe you did not stand in the right position. If you are taking measurements of maybe acids using burette, the meniscus, maybe you did not stand in the right position to take the measurement. So that is what we call parallax error, mostly due to human. But when we're talking about zero error, we are talking about not calibrating or the machines not working very well, the measuring machines. For example, if they want to weigh meat on a scale, sometimes you observe that the scale it has even passed zero. The pointer has passed zero and they did not put anything on it too. So these are some of the errors that comes from the machine and they are regarded as zero error. So how do you know? How do you know? How do you answer this question? So the least possible error is always half its smallest division. Very key. If you know this, they might decide to ask you, the calibration of a weighing balance is in kg, 1 kg, 2 kg, and so on. What is the minimum error that can be encountered when using it to measure? So if you know the normal principle, it will be very easier for you to answer this question. It is always half the smallest division. So if my ruler is calibrated in 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter, so which means the calibration, the smallest possible division is 1 centimeter. So half of it is usually the minimum error I can encounter when using it to measure. So in the case of meter rule, we have 1 millimeter as the calibration, usually or typically that's what you have. So the smallest error you are likely to encounter is 0.55 millimeter. So that's the correct answer. The correct answer is C. Let's continue. I say I don't want this to be too long. All right. The second question says a quantity which requires magnitude and direction to be specified is. I remembered giving you several assignments on this topic in one of the videos I've treated. Refer to it and refresh your memory. Okay, so I said there that scalar and vector quantities are quantities, while one have direction, the other one has only magnitude. So when we talk about magnitude, we mean you can weigh it, you can measure it, but there is no specified direction. For example, if you say distance can be east, west, north, and whichever way. So you have not specified direction. But when you are talking about displacement, you now say a boy moved 3 kilometers to the north. That's displacement from point A to point B. So we know direction and we know the magnitude, the measurement, which is 3 kilometers. So that's the difference. Stuff like temperature, they don't have direction. They have magnitude. You can say temperature 20 degrees Celsius, yes. But in what? Does it have direction? No. You cannot say 20 degrees Celsius right, 20 degrees Celsius left. So these are all scalar quantities, but displacement is the correct answer. Hope you get this. All right, question 3 says Roman number 1, electric potential, 2, torque, 3, kinetic energy, 4, momentum. Which of the quantities listed are vectors? Can you see? After asking of us, okay, they see ask of vector in the first question. Yeah, and they are still asking of vector. Very important. We've answered some questions, I think, on vectors. Was there a video I made that answers questions on vector, or I just explained it? I can't really recall because I've made many videos on physics. So most likely you see, if they ask 1, 2 questions, 3 questions under the same topic, don't play with that topic. Don't play with that topic. Don't play with that. Make sure you'll be able to answer questions on that topic, because they must ask every year. That's how it is, and I've observed that over the time. So let's go. right into this. So which of these quantities listed are vectors? Okay, so torque and momentum are vectors. Torque and momentum are vectors. But electrical potential, though it has magnitude, no direction. Kinetic energy, though it has magnitude but no direction. But when you talk about torque, you are talking about momentum. This has both magnitude and direction, making them become scalar. Question 4 says, which type of motion do the wheels of a moving car undergo? So a moving car undergo both translational and rotational motion. You know, as the wheel is rotating, it is also changing position from point A to point B. The car is moving. So translational motion has to do with a movement from one location to another in a linear way. That's translational motion. Then rotation has to do with about moving about a fixed point. So as the wheel is rotating, the car is moving. So the tire is undergoing two kinds of motions there, which is translational and rotational motion, making D the correct answer. Okay, vibratory and translational. Okay, vibratory has to do with atoms in an object or in a matter about a fixed point, especially in solids. They vibrate around a fixed point. You know, random motion. A woman moving around in the market, you know, just randomly, or a butterfly moving in the air. You know how their movement used to be randomly. Yeah. Okay. So oscillatory motion. Oscillatory motion. Do you remember simple pendulum? You remember your helical spring? Yeah. So this type undergo oscillatory motion, to and fro, up and down. Yeah. So question 5 say a car accelerates uniformly from rest at 3 meters per second square. Its velocity after traveling a distance of 24 meters is, so they're asking velocity here. Don't forget the 4 equations of motion. Oh, there was a video I made that I treated this exhaustively, and I've answered questions with simple illustrations with clear explanations. Please and please, I urge you, you can't avoid question under motion. So I advise that you should locate that video also in the playlist, physics playlist, on this channel, and watch it after you finish watching this. So here we are going to apply the equation of motion. Remember, they are asking us of velocity, and one of the equations of motion to calculate velocity is v square is equal to u square plus 2as. We have another one we have another equation also for calculating velocity. You have to memorize these equations and know which to apply. How do you know which to apply? Check what is given in the question. For example, here we are given acceleration, which is a, and look at our equation. We have 2as there. Yeah, we are given our distance. Distance is s, so it is given to us. Then initial velocity, since it starts from rest, initial velocity is always 0. Can you see? So we have to calculate final velocity. So our u is 0, a is 3, s is 24. So you just substitute everything into the formula and you get your final answer as 12. I hope this is clear. Because by the time you say 0, okay, you say 2 times 3 times 24, you get 144. Remember, in this formula, you have v square. So v square, you are not looking for v square, of course, you are looking for v. So to remove that square, you take the square root of the other side and remove the square from this side. That's the mathematical rule you apply. So if you take the square root of 44, that will give you 12 meters per second. If anything is not clear, please feel free to reach out to me through the comment section. I will attend to you once I come and see it. Thank you. Let's go. Question 6 says calculate the escape velocity of a satellite launched to the Earth's surface if the radius of the Earth is 6.4 times 10 raised to the power 6 meters. Oh, so this is talking about escape velocity, and I'm trying to recall. Okay, gravitational force. Yes. So we are talking about gravitational force and things around that. So we have what we call escape velocity. Some of you might have heard or might have been taught that in the space there is where you can reach that the force of gravity is very, very low, such that even heavy objects, if thrown in air, can float. Like in the moon, we know astronauts, when they move there, uh, we learned that they usually drag when moving. Yeah, they usually drag their legs because the force of gravity there is too little to bring them down, unlike here on Earth. So now when we are talking about escape velocity, we are talking about those locations where the velocity is really, really low. When you continue moving in high altitude, you would reach a point where the velocity is very low. Oh, I remember this story I've heard. I don't know how true it is, that there was a plane that once got missing in the sky, and scientists suggest that this plane has gone beyond where the force of gravity is. So even if the fuel finishes, it will just be floating like a nylon in the air. All right, so how do you calculate this escape velocity? This escape velocity has a formula, and you always apply it when calculating escape velocity. So the formula for escape velocity is equal to the square root of 2gr. R talks about radius of the earth, which is given in the question. G talks about the force of gravity here on earth, because we are now dealing with earth. If it is moon, they will give you the force of gravity for the moon, whatever the case may be. So that's simple, so simple. Just put in your values and multiply, then you get your answer as 11.3 kilometers per second. Remember, it's velocity we are calculating. All right, so, and D, making D the correct answer. So let's go. Another question in this same area. Wow. So I urge you, please look at these things very, very careful. Very important. So a similar question in that area. Now this question says an object of weight 80 kg on Earth is taken to a planet where the acceleration due to gravity is 1/3. Do you see this now? Somewhere the acceleration due to gravity is 1/3 of its value here on Earth. So the weight of an object in the planet is what? Good. So remember, weight is equal to mass times gravitational force. How heavy an object is dependent on mass and gravitational force. You now see this? So this is what makes objects float in the higher altitudes or in other planets, because the force of gravity there is very low. So, and the force of gravity is what determines their weight. So they will not be heavy. I hope you are getting this explanation. So now on Earth, the force of gravity is 10 meters per second square. So if we now want to calculate the weight of this object on Earth, it will be 80, which is the mass, times gravitational force, which is 10, to give us 800 newtons. Now on the other planet, we say the force of gravity is 1/3, which is 10/3, is 1/3 of that of the Earth. I hope you get this mathematics. It will be 1/3, that's 1/3 of 10. Do you remember your fraction? It will be 1/3, 1/3 of 10, which is 10/3, the same thing. So it will now be 80, since weight is equal to mass times gravitational force. So it will now be 80 times our mass, our acceleration due to gravity now is 1/3 of that of Earth, which is 1/3 of 10. So which is 10/3. So it will now be 80 multiplied by 10/3, which is 27. So let's go. Question 8 says, one of the conditions necessary for an object to be in equilibrium when acted upon by a number of parallel forces is that the vector sum of the forces is... Oh, if you are my student, you know that I've done video on vectors. I've given you several assignment questions which you have submitted. Yes, but if you are just coming across this for the first time, you can as well go and learn. Those videos are resourceful. They are going to be very, very helpful. Yeah, they are going to be very, very helpful. So we are talking about forces. Remember, I taught you addition of forces acting on the same direction, vectors acting on the same direction, vectors acting on opposite direction, vectors acting at an angle. All this, I have treated it. So for an object to be in equilibrium, it means that it is not moving. So probably the opposite forces acting on it are equal. For example, if two children are dragging a chair, both are in opposite directions and their strength is equal, what do you think will happen to the chair? Will it move? No, it will be in the equilibrium because both of them are applying equal amount of strength on the chair. So it won't move. So that's equilibrium. What if the strength of one is greater than the other? What do you think will happen? The chair will move a little in the direction of the stronger boy. Did you get the question? So that's what we are being asked here. So if an object must be in the equilibrium, then it means the sum of the forces is equal to 0. 0. Remember, if the forces are acting on opposite direction, what do? You subtract. That will give you the resultant vector. If they are acting on the same direction, you add. I have treated all this. I can't continue. So sorry. I don't want the video to be too long. In fact, even at now, I feel. So let's go. I have 20 questions and I'm already at 9. Let me be faster now. All right. So what happens when three coplanar non-parallel forces are in equilibrium? Now, when you have parallel forces in equilibrium that are coplanar, that's non-parallel, what happens? So their lines of actions meet at a point. Their lines of action meet at a point. So coplanar non-parallel forces in equilibrium must intersect at a point to balance. So if there must be an equilibrium, they must intersect somewhere. Alright, so question 10 says an object of mass 20 kg is released from a height of 10 meters above the ground level. The kinetic energy of the object just before it hits the ground is... This is very simple. You remember your KE, you remember your PE. Do you remember that? Yeah, which is equal to mgh, mass times gravitational force times height. That's as simple as that. So we are given the mass, which is 20. We are given the height, which is 10. And we know the acceleration due to gravity, which is 10, because we are dealing with Earth. So the final answer will be 2000 joules. I hope you are understanding. If any question is not clear, to my student, I will send this to the group, to the WhatsApp group, please. Remind me. Someone should just remind me, even on DM. If you are not part of us, you can just say you are interested just in the comment section. Just write interested. I will add you to the WhatsApp group so that you can have access to other resources my students are enjoying there as you prepare for this year's JAMB. So question 11 says the energy in the nucleus of an atom produces heat which can be used to generate kinetic energy. Nuclear heat is typically converted to kinetic energy. Yeah. Like in steam turbines. Though electric energy is the end goal. Okay, so let me explain this. Now we have what we call generation. We generate electricity in different ways. Yeah, we generate electricity in different ways. One of them is hydroelectricity through water. Then we have what we call generation of electricity through radioactivity, through nuclear plants. Now what happens? Remember, during fusion, or let me rather use fission, decay, when radioactive substance is decaying, we learned that it is accompanied by the emission of large amount of heat. Do you remember that? Yeah. Okay, now let me give you a picture of what happened. Now, if you have, let's say you dig a hole and you now put radioactive elements. Now, as they are decaying, we learned that they emit huge amount of heat. So, assuming you now pour water, as these radioactive elements are decaying and are emitting huge amount of heat, what do you think will happen? Now, if you pour water on coals, what do you usually observe? You see a kind of forceful emission of steam. So that's what exactly happened. So as you pour water, in fact, the water will not reach the liquid. As the water is touching the radioactive element in the hole, it is turning into a forceful steam because of the high amount of heat there. More than 100 degrees Celsius, 1000, some of them. In fact, the temperature is very, very high. So do you get what I'm trying to say? So to generate electricity with it, it's more like they will now put that radioactive substances in a hole. Now they will now put the turbines. You know, turbines usually they are more like something like drums that will be turning. That will be turning. Do you get it? So they will now put them at the top. So by the time they are pouring water into the radioactive substance, the steam is coming forcefully and hitting the turbines. So the turbines will continue turning. So water is falling on it and the steam is coming forcefully and is turning it. So as the turbines are turning, electricity is generated. Who got this wisdom? All right, so you see, science is interesting. Science is interesting. All right, I just wish I have a lot of time with you guys, but notwithstanding, my student, remember, our plan is even beyond JAMB. I want to see that you people prosper. So even while you get your admission in the universities, this channel will still be active. I will still be seeing how I'll give you support to emerge as best graduating candidates by God's grace. Remember, I'm a first class graduate. It is possible for you to graduate as first class student. Yep. Let's go. So I've explained this already. Question 12 says a machine whose efficiency is 75 is used to lift a load of 1000 Newton. Calculate the effort put in the machine if it has a velocity ratio of 4. Yeah, mechanical advantage, velocity ratio, efficiency, and so on and so forth. All right, so here we are asked to calculate the effort put on the machine. So to calculate the effort, we use a formula. Mechanical advantage is equal to load over effort. So if you make effort the subject of formula, you'll be able to calculate it. So first of all, we have that efficiency is mechanical advantage over velocity ratio times 100. So, but efficiency is given. So we have 100 as efficiency. And then we have velocity ratio also given. Velocity ratio is given. So by the time you substitute your effort, your efficiency, and your load, we have load. Effort is not given. So remember, we're using mechanical advantage is equal to load over effort. So we have 1000 over effort times 1 over 4. Sorry. Times 1 over 4 times 1 over 4 times 100, and this is equal to 75. So if you make E the subject of formula, you are going to get 333.33 Newton. Yeah, I don't want to hear my students say 333.33. No, 0.33. Anything behind decimal point is red, not, you don't count it as a number. All right, thank you. Hope you got this. 13 says a wheel and an axle is used to raise a load whose weight is 800 Newton when an effort of 250 Newton is applied. If the radar of the wheel and axle is 800 millimeter and 200 respectively, the efficiency of the machine is, okay, this time around we are calculating the efficiency. So to calculate efficiency, we need to calculate velocity ratio, which is 800 over 200, and this gives us 4. The mechanical advantage will be 800 over 250, which will give us 3.4. So the efficiency, we know that is equal to always mechanical advantage over velocity ratio times 100. And this gives us now 3.2 over 4 times 100, which is equal to 80%. I hope this is also clear. All right, so observe something that we have answered 2 questions. These JAMB questions are for 1 year, 2014. Now observe that 2 questions have been asked under this topic, which shows that they are interested in you knowing it. All right, so we continue. A force, that's 14, a force of 500 Newton is applied to a steel wire of cross-sectional area of 0.2 meters square. The tensile strength is, okay, this is very simple. Okay, stress is equal to force over area. Simple. Stress is equal to force over area. And this is equal to 500 over 0.02. You are given area, you are given force. So you just divide and get your answer, which is 2.5 times 10 raised to power minus 3. Okay. Oh, why is this thing now? Alright, so we continue. I have question 15. A small droplets of water that form on the grass in the early hours of morning is called what? Droplets of water. Droplets of water in the early hours of morning is called what? Dew, of course. Yeah, you know that. What is the equivalent of 20 Kelvin in Celsius scale? 20 Kelvin in Celsius scale. 20 Kelvin in Celsius scale. Now this is very simple. What is 0 degree in Kelvin? 0 degree is 273. That's 0 degree. So if you know 0 degree, you can easily know 20 degrees Celsius. So you are going to say 0 degree is equal to 273, then 20 degree is equal to x unknown. Cross multiply and divide. Then you get the final answer, which is around 293. Okay. But remember, from degree to Kelvin, this is from Kelvin to degree now, but from degree to Kelvin, you just add 273. For example, if I say change 5 degrees to Kelvin, it's going to be 273 Kelvin plus 5. That's the answer. Okay, the next question, 17, we're almost done. We're almost closing. 17 says the equation PVT is equal to constant reduces to Charles' law if... Okay, now they are asking us, what is Charles' law? Do we really know it? Especially the mathematical expression. So what will happen for this equation to reduce to Charles' law? Now we remember that Charles' law talks about volume and temperature provided that pressure is constant. Do you remember? While Boyle's law talks about pressure and volume provided that temperature is constant. Do you remember that? So I hope you didn't forget. So now for this equation to change to Charles' law, remember Charles' law is V over T. Yeah. V1 over T1 is equal to V2 over T2. Do you remember the formula? So now if this PVT is equal to constant, remember, right from this, you know that Charles' law doesn't have pressure. And in the equation given here, there is pressure. So automatically the pressure must go. So which means that A has to be 0. So that P raised to power 0, P will vanish. I don't know if someone is getting my explanation. Okay, well, let me assume so. So, of course, so for the equation to reduce to Charles' law, we have to have our A will be 0, so that P will vanish. V will be raised to power 1, so that V will remain as it is. And then T will be raised to power minus 1, so that it will be over T. Do you know that T raised to power minus 1 is the same thing as 1 over T? Do you get that? Yes, that's how it is. So for T to come under V, so that it will be V over T, for it to change into Charles' law, T has to be raised to power minus 1. So the correct answer is D. A must be 0, B must be 1, and C must be minus 1. I hope someone got this, so let me round up. The quantity of heat needed to raise the temperature of a body by 1 Kelvin is the body's heat capacity, correct? And that's A. A is the correct answer. Alright, so let's go to question 19 that says the melting point of a substance is equivalent to its solidification temperature. This question is confusing. You have to get it too. Very important. Now, what's the melting point? Melting point is the temperature at which a solid changes to liquid, right? Yes, that's the melting point. Now, at that same temperature where the solid changes to liquid, okay, let's say it has changed to liquid now. At what temperature will it change back to solid? is at the melting temperature. Because as the temperature reduces, it will start becoming thick liquid, thick liquid, thick liquid. Once it reaches its melting point, it will turn to solid. So you have to get this question very, very well. It's a kind of confusing, because I know so many people will choose liquidification temperature, and that's wrong. That's wrong. I know you will not choose solidification pressure or vapor pressure, but this liquidification temperature is tempting, because you feel as if melting temperature is the substance not changing to liquid, so it's liquidification. No, no, no. So I hope my explanation is clear. Let's look at the last question. The temperature at which water vapor present in the air is just sufficient to saturate air is called what? It's called dew point. It's called dew point. I've explained this dew very, very well in one video. I don't know if I can remember. Yeah, I did in one video. You know, during the rainy season, the air becomes filled with water. It becomes humid. For example, now everywhere is humid already. The air, you can feel the moisture in the air when wind blows. You can feel the moisture. So that's humidity. Now, at night, when the temperature drops, do you get it? So the water condenses and fall on the grass. So the temperature at which the water vapor present in the air is just sufficient to saturate the air. Now, if the water saturates the air, if you dry clothes, it can take a week and they do not dry. Those that lives in places like rivers, they know this. There was a time I was in rivers. We put out precisely. We washed clothes for where clothes clothes no gree dry. So what is the explanation? The explanation was that the air that's supposed to carry the water from the clothes itself is already filled with water. So it carries no water from the clothes to help it dry, or it carries a little water. So that's that. Oh, I have many questions. I will continue in the next video. Thank you everyone. God bless you. If you have not liked, subscribed, made comment, please do so, as I will continue to drop more and more videos, God willing, to see how I can support you. But Sha, I hope you have learned something through this video. You did not waste your time. You have learned something? Let me know. If you have watched to this end, I know my students, they will always watch till the end. They want to hear the last word. I will say, okay, let me know who watched. Just say, I have watched this video to the end. If you have learned something, say, I've learned something. If you are a new student and you're interested in joining, just use the comment section to say I want to be part of you, and I'll find a way of adding you. Thank you very much. We meet in the next video. It won't be long that I'll drop the next video. That's on the remaining questions for this 2020-2014. Thank you and God bless you.